Thanks, Alon. And as Alon said, my research is in developing underwater robotic grippers. So you might thinking to yourself, why should I care? Well, let's think about this for a second. Imagine you're a scuba diver and you've been given a few jobs. You've been told to help with underwater construction to help build these oil rigs, or retrieve these black boxes that have been lost because of airplane crashes. Or, let's not forget, conducting research in these delicate environments, which is what many Oregon State University students do. So what we need is something that acts like a hand underwater in these fragile environments without harming anything. We need something that bends when we want it to bend, something that's strong enough to lift heavy objects without slipping or dropping them, and something that's careful enough to not damage the object itself or its surrounding. What we need is robotic grippers. So let's look at 3 types of robotic grippers. Firstly, we have a hard hand, and these are mostly used in land environments because their components are very electrical. As we all know, do not put electrical components in water. Then we have soft hands, which is what I'm working with. And these are very widely used in underwater environments because they're easy to waterproof. Then we have a combination of both hard and soft, which is called hybrid hands. And though these look really cool, they're kind of new and very hard to waterproof and may sink at times. So, what I narrowed my focus to is on soft robotic grippers. Like I said before, they're easy to waterproof. So my research started at looking at these little guys called new nets. Not old nets, but new nets. I was figuring out how they worked and if they worked for what I wanted to do. But what I saw in soft robotic grippers is that they cannot pick up heavy objects, which is you kind of see it. So this led me to my main question. And this is my main question for today. And how can we improve these type of soft robotic grippers? So, the solution is variable stiffness. So when working with robotic hands, we define stiffness as the resistance to bending caused by external forces. So for example, say you need to get under rocks to collect a soil sample or something fragile. You want to have high stiffness to maneuver under these rocks and low stiffness to actually carry the object without harming it. So in order to do that, we need to use this process called particle jamming. So that means putting some solids like coffee grounds, marbles, glass beads inside the hand. And remember, there's still air in there. First, the robotic gripper, shown here, it starts in its soft state. Then it surrounds the object and deforms around the object here. Then all the air is sucked out. And finally, you can actually lift the object. So this little boxing glove looking thing is not what I'm working with, but I am using the concept in particle jamming with a new net. So remember when I showed the original new net, and it did this? It has no stiffness and just went in a circle. So what I did is add jamming inside this new net by putting coffee grounds inside. And what I found here, you can actually see how it is when it's kind of fully jammed. So now, theoretically, you should be able to hold heavier objects because it has some stiffness. You can actually vary the stiffness by changing the amount of material, the quantity of material, and kind of the air too. So now that we understand how jamming is used, we want to apply this concept to other places. And this is a diagram of a suction cup with jamming. So we all think about suction cups and how they work. They have to make contact with these surfaces. But what if you want to make contact at these angles? In other words, you need it to bend. So for example, because there's jamming in there, it will force itself down at an angle. And by adding jamming in there, it has some flexibility and stiffness, yay, which is what we want. So my theory is if we use a bunch of these little suction jammers, they will attach to different angles and actually hold these irregularly shaped objects. And you'll have enough gripping power to actually lift them. So that's what I'm working on right now. My future goal, future work, would be in creating a type of visual simulation or interface that has all this together so that researchers and any other people that are wanting to use this tool can actually use it at their own disposal. And with that, that's the end of my presentation. Thank you all for coming.